Hey everyone, today on the show I am talking with scientific journalist and author Sally Adey. Sally has a new book out called We Are Electric. And this is a really fascinating book about how our bodies are electric and the science or the study of that electricity over the last 200 years and where it could lead to in Tomorrowland. Anyway, I think you're really going to love this conversation. Sally uncovers a ton of just neat stuff about our bodies and the possible future of medicine. All right, guys, thanks so much for listening to the Original Strength Podcast. Pull up a chair and buckle up. It's the Original Strength Podcast.
So, Sally, you are a scientific journalist and an author, and you've recently written a book called We Are Electric.
That's right.
And I really found the book fascinating, especially from a historical perspective. I mean, it was just neat, right?
Yeah, I like to think so.
But before we get into the history of being electric, what sparked your fascination about trying to learn about electricity in the body?
Well, so I started my career at an engineering magazine called IEEE Spectrum. That's the Institute for Electronics and Electrical Engineers. I actually got that backwards. It's Electrical and Electronics Engineers. Um, so when I was there, I was on the semiconductor beat. And while that was sometimes excruciating, trying to learn about transistors and, you know, one of the things that was really amazing about that was looking at the development of both sort of neuromorphic chips that were being designed to mimic the hardware that the brain uses to process information, and also the signal processing algorithms that people were using to extract electrical information from the brain, or rather, sorry, to interpret electrical information that you could get from the brain using either, surface electrodes like EEG or invasive implants like Utah arrays, and using those signal processing algorithms to extract such useful information that you could, drive a robot arm to, if just with the brain signals alone. People who had spinal injuries, for example, were using robotic arms to do things like pick up grapes and eat them. And apart from that, the rise of neurally integrated prosthetics was also fascinating. And I really wanted to understand what is the interface between our biology and these, fundamentally electronic devices that we were using to either harvest the signal or in some cases even drive a signal back into the body to actuate, limbs and stuff. So I really got interested in that interface, that place between biology and engineering. And the whole thing kind of came to a head in about 2007 to 11, when I reported on a project that was being undertaken at DARPA, which is the Defense Advanced Research Projects Agency of the US military, where they were applying electrical stimulation non-invasively to the head in an effort to double the speed at which you would go from being a novice to an expert at things like sharpshooting or mathematics or language acquisition. And I thought, that's nuts. Like, there's no way you could just zap someone on the brain and expect to get that kind of return. But then, of course, after sort of pestering them for a few years, they did let me come out to California to try it out for myself. And for me, it was really transformative. I had a fairly wild experience with it. And after that, I sort of spent the next 10 years falling down every available rabbit hole. And the book is the result.
I mean, that is kind of wild. And it sounds like your background, you were already primed and ready, like to explore this. So I guess the big jump start for you was somehow the military shocked your brain and made you into a sniper.
Well, I mean, not an actual sniper, like virtual. So they did, So they sent me out to the offices of a contractor, one of the contractors on the project. The project was called Accelerated Learning. And they sent me out to California to try, a simulation that was as close as possible as what they were actually doing in the field, which, I mean, they did a really good job. They had kitted out a room to resemble, I guess, the training simulation that someone in the military perhaps undergoes. Probably, I mean, I think they use this program. It's called Dar Wars Ambush, and they were projecting it onto a wall, and across the room I was behind some actual sandbags, and I was, I had a modified rifle. It didn't shoot bullets. It basically just it aimed properly at whatever target I was practicing on. Now, the issue there was I had made some really bad choices in the run-up to reporting this story. First of all, I decided that I was going to take that 11-hour, red eye plus flight from London to California without even a day to adjust before I was going to try to report this complicated story about how an electrical field applied to your neurons could get you into the flow state, which is, that's a bold choice. And then I decided that I was going to save New Scientist some money and not even stay at a hotel, but stay with a buddy of mine who lived in the mountains. And so this was a massive, I had altitude sickness. I was jet lagged. It took me 2 hours to, crawl through the California traffic to get there. So by the time I started with, sniper training or virtual sniper training, I was already so distracted by how much I hated myself. I was so mad at myself for, walking into this thing with only sort of maybe half a brain, if that. And so I was really distracted. And also, first-person shooters are not my game at all. I'm horrible at them. And so I just, I was so hapless, just, it's just so bad at this. I don't know if words can communicate how badly I was screwing it up. And so they kept putting me through these, and they had put the TDCS kit on me. I mean, obviously this was a gonzo stunt kind of thing, right? There's no way that this was going to be a scientifically reproducible result or something that I should report as if it was actual science. It was just a sort of here's what it feels like type of story. But they said, in order to make it sort of as realistic as possible, they said, we're going to put the battery pack behind you, and the scientist will come in every once in a while and fiddle with it. And you're not going to know whether or not it's on, just to make it as sort of plausible as possible, right? And so he came in a bunch of times, but I was terrible at this training simulation. And I was getting angrier and angrier with myself and just distracted. And I was so bad. Every time I, got anywhere into the simulation, I got blown up immediately. And then I would have to sort of respawn and then get blown up immediately. I don't know how many times I went through this. And each sort of trial session was about 20 minutes. That's how long it would take if you were actually going to do well with this program. And so finally he comes in, and I'm sort of at my low point. I'm kind of near tears at this point. I just want to go home. I just want to forget all about this. I'm like, why did I even want to report on this? And so then he comes in and he turns on the electricity, and I could tell I've got a little retainer, and it sort of started to taste like metal in my mouth. But I was just like, well, now what's going to happen? And initially nothing happened. So I picked up the gun again and I started the simulation again. And it seemed like no time passed. I suddenly picked off every single one. It was this very dramatic experience where all of a sudden, all the distracting sort of wasps that had been buzzing around my brain, they stopped. And I was able to just focus on what was in front of me in a way that was, it was so much easier to be able to focus and concentrate when I didn't have all of this sort of angry noise in my head. And so after a very short time, I had picked off all of the attackers, which I hadn't done in any of the run up. And the tech walked in and she was like, all right, you're done. She turned on the lights. And I was like, well, wait a second, where's the rest of it, basically? And she said, no, this is it, you're done. And I said, well, how many did I get? And she said, well, all of them. And then I said, well, I was mad at that point, because I thought, you've been torturing me for most of the day, and now finally I get it right. And you stopped the program early. So I said, well, how long was I in here? And she said 20 minutes. And I could have sworn that it was like at most 3. So
Wow.
I guess, that was a little bit long-winded, but for me, it was just so dramatic, to suddenly be free of all the sort of angry little defocusing voices in my head. And it took about 3 days to, go back to my sort of, I guess, ground state, mental state. I had a really interesting 3 days of walking around just free of all that.
So you found your true flow sniper state.
Yeah. And it wasn't just for during the experiment. Afterwards, when I was driving home, I had to sort of beat rush hour California traffic, or not beat, but just be in. And normally I'm a little bit of a nervous driver, kind of quite white knuckling it. But when I went through that, driving was completely fine. Like, I was sort of aware of where everyone was around me. There was just no panic. There was just like, it had dialed down this entire sort of system of anxieties in me so profoundly. And, I don't know, I found myself like 6 months later, I was at like a work event, and somebody was asking me about the story, and they were just like, oh, that was so interesting. And like, would you want to, get something like that for yourself? And I was really surprised. I almost welled up in tears because I thought I was about to, I was like, yes, I really, really want to get one, again, because it was a really dramatic experience.
Wow. And that led you to write the book.
Yeah, it's slightly indirect, because so what happened afterwards was, so that article, I think a lot of people read it, particularly people who were like me, very interested in how to maybe escape some of the nonsense that their brain threw at them.
Right. No, yeah, it sounds like
And
you had a major spiritual experience.
yeah, it was just it was revelatory, because it made me realize that like this, I hadn't noticed all that sort of shouting in my head. It was kind of my brain's elevator music. I just sort of went through, or like supermarket music, you kind of go in and you're just like, oh, there's something slightly annoying in the background, but I'm just going to try to go about my business. But when it got turned off, it just made me realize that there was a whole person in there who could just do stuff instead of first doing these like ritualistic, self-recriminating dances. And, it was just so incredible to think that there was somebody like that in there, and that they needed rescuing. So I've made a lot of major lifestyle changes since then. I started meditating, because that was something that, if you like, when I can have the focus to do that, it really it gets very close to that experience. I stopped drinking alcohol. Like, it just, I went pretty nuts, like looking for how to replicate that experience as well as I could. And yeah, I think just being aware that there's a person in there who you need to rescue from the unhappy, I don't know, voices. It wasn't like I said, it wasn't like voices in my head. It was just a weird background chatter.
All the clutter.
Yeah, the clutter. So what was super interesting was many years later, when I was researching the book, I spoke to a neuroscientist who uses TDCS to treat depression. And she said that there are several different phenotypes of depression. There's, some kinds of depression are the kind where you can't get out of bed, you just can't move. there's other kinds of depression where like they're sort of an anxious depression where people will just report like exactly that weird wasp's buzz, of just like angry little, like just background chatter. And she said that in her study participants, when she put the electrode placement that I had on them, on that particular area of the cortex, she said that for those types of depressed people, their symptoms cleared up very dramatically. And I thought that was really interesting because, that's a sort of, that seemed like the beginnings of a mechanism, to make that work. But yeah, sorry, I'm getting a little bit off topic with my experience, but I think
that is cool.
That's the power of the sort of, the electric signals that flow through your body.
That is awesome. So, man, okay, so yeah, now I don't even know where to go. But okay, so you had that experience and the science behind that kind of led to those experiments that opened up your brain to a flow state.
Oh yeah, sorry. I realized where I cut you off and fell down another rabbit hole. Sorry. You had said, so that led to you writing the book. And I was saying about how it was indirect, because what happened is once that article went fairly, that, a fair number of people read it. What happened after that is, people started, a lot of other researchers started looking at the fairly new science around transcranial direct current stimulation. And there were a couple of big meta-analyses that concluded that when you look across all the different studies, which were all very small because this was early days, actually, when you averaged them out, there was no effect of transcranial direct current stimulation. There was just nothing scientifically, valid about it. And so there was this little backlash. And a lot of the people who were saying that it was basically snake oil pointed back at an era of electroquackery in the 19th century that was like just extraordinary. Some of the early experiments with bioelectricity actually motivated Mary Shelley to write Frankenstein. Because people were sort of using this early version of a battery to zap recently executed prisoners. And this was sort of scientific, but it was mostly spectacle. A lot of the people who attended these were, royalty and other sort of people who were expecting like a parlor game kind of thing. So people would watch these, poor prisoners' bodies being reanimated, not like actual Frankenstein, but just, briefly, like you would put like an electrode in their ear and zap them, and, they would like make horrible grimaces, or they, would lift an arm. And, there was one instance where one guy, lifted his arm and his finger sort of uncurled into like an almost pointing gesture, and the person he pointed at just fainted away dead. So, and then after that, it just got worse and worse. People were making these like galvanic belts and rings and bracelets, and none of them had any idea of like the mechanism at the time, because we didn't have tools sensitive enough to actually understand by what mechanism electricity could possibly be interfacing with the body. But that didn't stop people from trying to make money off it. So they had, one guy, he made something called the celestial bed, which was allegedly something to do with electricity that infertile couples could use to, get pregnant. And it turned out that there wasn't even any electricity involved. It was like homeopathic electricity, because electricity was such a fascinating phenomenon at the time and it was so mysterious, and people are still trying to get to grips with it and figure out like how it's all involved. And, they were just trying to figure out how it all worked, to the extent that it was just such a like sexy idea that that's all they really needed to sell stuff. Anyway, 200 years later, it became clear that bioelectricity is real, and that it's a really like wild and just potentially incredibly fruitful area of research. But a lot of the very rigorous scientists who are trying to understand these mechanisms still have trouble getting grants, because people look back on that era of electroquackery and they say things in the proposals, when they're responding, like, does anybody still believe this shit? And that era of electroquackery hurt the field so much and continues to reverberate. So that really sent me back into doing the deep dive on the history of it. And but it also helped me to figure out like what is the hallmark of electroquackery, and how do you separate it from the really rigorous good science that's being done today to advance this, area of science. And when I was able to have that knowledge, I decided that my book, I really wanted it to be like a repository of all the good science that's being done and all the stuff that's really strongly supported. And I just wanted it to be all in one place because I just hadn't seen that yet.
No, yeah, and I think you did a great job, like, especially because to me this is like the new frontier of science and medicine, right? But yet it's almost over 200 years old. And it is fascinating to think that there are still frogs around on the planet today with all the experiments that people seem to do on frogs to try to determine if the body had electricity in it or not. I mean, so that stuff was just fascinating. Although some of it was weird, like with electrodes up rectums to see if people could.
Oh, I know. I mean, alive. It's a lot of self-experimentation was pretty hardcore back then, because I think, in some ways, like, before the scientific method got really truly validated and, standardized, what else did you have? Sometimes you just needed to find out for yourself. So,
right.
That led Alexander von Humboldt to actually, perform, I think, like 4,000 electrical experiments on himself. That's friend nuts. Actually, he roped in a friend of his, and his friend died in his 30s because his nervous system was so fried. But Alexander von Humboldt did one of the most sort of startling of these experiments, where he took one of these little wires and he put it up his own rectum, and he put it up there until he's, and he really wanted to understand like what happens when you do this. And, he saw lights and, patterns flashing in his eyes. And I don't know if you could go further to demonstrate your commitment to understanding bioelectricity.
Yeah, you proved to yourself that electricity is electrifying. It's weird. So, but like, and now today though, like with the research you've done, like, well, I'll ask you this because this is fascinating to me because it makes me think of Thunderdome. What is the electrome?
Oh yeah, no. So the electrome is the, I guess, so this was, the first time this was put in a paper was about 2016. But this was one sort of approach to sort of understanding or to trying to define it. But elsewhere, like a lot of researchers have said that they, elsewhere, a lot of researchers have wondered, how to come up with an adequate definition of the electrome. People have been writing it in, peer-reviewed papers. And, so one of the things I was trying to do with my book as well is to sort of pin down a definition that like multiple researchers could agree on. And what we came up with was the electrical dimensions and properties of cells, subcellular compartments, organs, and, entire organisms, and how these relate to the other aspects of that organism. Because in some cases, it's quite clear that the endogenous bioelectricity that we generate has like really powerful, almost like epigenetic influences on stuff like gene expression. So one example is the wound current. So your skin cells are just like your sort of nerve cells and muscle cells, in the sense that they press their electric properties into service. Now, in the nervous system, it's used to do like the major central communications relay station and hub. The brain controls the limbs by sending electrical messages, and all of that, the mechanism that underpins your entire fundamental experience of being human, the ability to sort of see and walk and talk and breathe and smell and taste, that's all electric. That's voltage. That's the neuronal voltage. But every other cell in your body also has a voltage. Skin cells have a voltage, and they link up together, obviously, to form this barrier against the outside world. And their inner voltage is maintained by a specific concentration of ions. And when you cut yourself, let's say you just cut yourself, those ions, which have very sort of tidy pathways that they use to go in and out of cells, they leak out all over the place. It's like a short circuit, right? And so the resulting current forms an electrical field at the wound. And this electrical field has its cathode at the very center of the wound. And that thing works like a beacon. It works like a bat signal. And what it does is it attracts all the little helper cells that are going to help you heal the wound. Keratinocytes that build everything back up again, the macrophages that come in and mop up the mess. And as your wound starts to heal, the strength of the electric field actually dampens until when the wound is completely scarred over, there's no more field at all. But what's really interesting, what they found more recently with the advent of better tools, is that that field is twice as strong in people who are under 25 as it is in people who are over 65. So it wanes as we age. And I think the thing that is wild about that is that they started to realize that, what if we could actually manipulate that field? What if we could figure out how to change it so that people might be able to heal more quickly? So they use things like ion channel blocking drugs or other types of ion manipulators to actually they were able to mess with the generation of the electric field and thereby slow down healing. And from there, obviously, the next step was, can we amplify the field so that healing is actually accelerated? There's a project right now, again with DARPA, where they're trying to figure out how to amplify sort of the endogenous bioelectric signals so that they can, again, reduce the time it takes from having a wound to having it healed by a factor of 2.
That's awesome. Like when I read the book, I couldn't help but, matter of fact, right after I read it, I cut myself in the kitchen trying to slice a sweet potato. I was being dumb. It's one of those things where you're thinking you're probably going to cut yourself if you don't do this differently, and you keep doing it anyway.
I did that over the Christmas holiday. I almost cut my thumb off trying to cut a lime. Stupid.
my brain was trying to warn me. Something in me was trying to warn me, and I'm like, it's gonna be fine. And it's sure enough, it was. So then, but I was thinking like, wow, could I take a 9-volt battery and like try to put it up next to it to like encourage healing to go faster, or could I drink something like Gatorade to like try to optimize my electrolytes?
No. I mean, yeah. I mean, I think that's exactly, well, I mean, they're not talking about 9-volt batteries, but they are trying to figure out exactly what they need to do in order to make that work. They know that it is possible in principle. They've been animal studies, but like, how are they going to, sort of push all the right little levers, right? And that's a lot of the work that's going on right now, both in TDCS and in electrical healing. They both have exactly the same issues that they're addressing right now. A lot of the studies are trying to figure out, what are the various parameters? Like, what does a wound look like electrically at various stages of healing? And like, how can we actually get in there and tweak it and tinker with it so that we can make the right things happen? With TDCS, for example, they're trying to figure out how to make it work in everyone. The problem is that, we are so different, all of us. I mean, and an electric current from a battery will affect all of us so differently. In order to do TDCS properly, there was this amazing study from 2016. It was really gold standard. It reviewed all of the TDCS studies. And while there were some really bad ones, most of them suffered from the fact that there's no standards. Like, we don't know what exactly, like what exact placement on the skull is going to do this or that. And then also, how long should the stimulation remain on for various, issues. You even have to take into account things like skull thickness, because, living bone is a conductor. So you have to figure out, how that factors in. And people are getting a lot more sanguine about figuring all this stuff out now, because largely, a lot of this stuff can be correlated using AI. So they're happy about that. But also, we're just getting better at winnowing down these parameters so that we can start making really good reproducible studies. Already in 2016, they concluded that the three things that seem to reliably respond to TDCS were depression, addiction, and I always forget the third one. I think it's anxiety. I can give you the link to the study if you want to link it from the podcast.
Yeah, that would be great.
But this was a real gold standard review. They really did their homework. But yeah, so sorry, now I've lost my train of thought. But basically, those are the things that's the major issue right now with electrical stimulation, whether it's for for brain stimulation, for invasive brain stimulation, or for non-invasive brain stimulation, or for electric healing. It's all the same thing. What are the parameters? How do we standardize them? And how do we make sure that we have something that we can use in a giant trial in a way that's really good science?
Speaking of good science, I thought, to me, one of the most hopeful things about the book is that how, if we could harness electricity and match it with our bodies just right, we could help heal and get rid of mental illnesses, but we could also help people live or survive cancer, where cancer is just not an issue. Or even, this was crazy to me, but like the possibility of growing back a limb or something that someone lost, like that's really Star Trek stuff.
Oh, it's super interesting. Yeah.
And the cool thing about it being Star Trek stuff, though, is almost everything that ever happened on Star Trek has eventually become to be something that we have. Like,
Yeah.
that is at our fingertips. So when I read that in your book, I'm like, well, dang, we are going to get to a point where people can just regrow things if they lose it.
Yeah, I think so. I mean, that's that's quite early days right now. I think the wound healing is quite mature.
Yes.
But the experiments in regeneration have been really interesting. I think what I really like about them is the theory behind it is quite interesting. There's two competing theories for regeneration, limb regeneration, right? So first of all, animals that can regenerate a limb, like, starfish, salamanders, they have, that wound current I was talking about. When you lop off one of their limbs, the electrical profile of the field that's generated is completely different from what non-regenerating animals show. So there is a school of thought that's like, well, can we just replicate those electrical characteristics? Is that going to be enough? But there's another school of thought. The competing school of thought is, humans are regenerators. Not always, like, we're patchwork regenerators in space and time. So right now, you have like incredibly regenerative cells in your intestine and in your liver. And then through time, it's even more dramatic, because when you're, a newly fertilized egg in the womb, somebody cuts you in half, you become twins, which is like, that's like how, planarians reproduce. They like reproduce by ripping themselves in half. So that's a very different regenerating profile. While you're gestating in the womb, you heal scarlessly, which is something that we found out when we started doing fetal surgery. When you are a child, until the ages of between 7 and 11, if somebody cuts off the tip of your finger, the entire thing will regrow perfectly, including the nail.
That's crazy. And I didn't know that until I read it. I'm like, son of a gun.
It's bananas, right?
Right.
So, but that ability gets lost as you pass that age range. And then that weird wound current thing kicks in where it's just like you just heal more and more slowly. So your ability to regenerate is age dependent. So then the other, framework for trying to regenerate limbs is, can we get ourselves back to that developmental stage? Can we get those particular cells back to that developmental stage? And basically just instructs the body to grow a new thing, just like it would in the womb. Now, obviously, there are a lot of, problems that could emerge if you do this wrong. Obviously, if you're trying to make cells divide and replicate really quickly, then you are very likely to get cancer instead of a new hand. But those two, like trying to figure out which of those two approaches is the way forward, is very much like the question right now. But there have been pretty dramatic results in tadpole models, frog models, showing that if you cut off a limb during a stage at which a tadpole does not typically regenerate, you can grow like an almost perfectly functional leg after chopping it off. So I think there's some stuff in mice that should be coming down the pike soon. They haven't done perfect regeneration, but it's kind of like, wow, like that thing grew, like a limb that doesn't look great, but it was usable. So it's
coming.
Yeah, I mean, the question is always like, can these insights be ported from model organisms like tadpoles and mice to humans? Because people assume that what's true for mice is true for people, but that's not always true. As you can see, there's most drugs that work in mice well enough to start a human trial do not end up being feasible in humans. So,
which is
we have to see.
That is interesting too, because then you get into the whole like the nutrition thing that all the studies they do with mice, and then they try to extrapolate it and put it on people too. And well, how accurate is that? Anyway.
Yeah, exactly.
So I want people to read this book because it's just a neat book. So I don't want to give away too much, but the book is called We Are Electric. And where can people find it?
So Amazon.com, definitely. I think a lot of booksellers have it. And I really need to memorize a better answer to that.
No, it's all good. It's all good. People are going to find it. Don't worry.
Okay.
So I got just a couple more questions for you. That state you found when you were the world's best sniper.
Well, I don't know if I was the world's best sniper, but I was worlds better than anything I had done earlier than that.
Well, the state where all the noise went away.
Yes.
Have you been able to find it since?
Like I said, yeah. I mean, I've really I've looked far and wide to find things that replicate that. I mean, it's obviously like it's nothing is going to be as effortless. But like I said, after I started looking into meditation, I was able to get there. It's just, it doesn't have a switch. It's kind of like you have to do the work. But I think there's I think if they can figure out how to make something like that for people, I think that would be I think for many people that would feel like a godsend. And right. Just very, revelatory.
Awesome. Well, here's to hoping, and that's in the near future too. Last question. Do you like peanut butter?
I do love peanut butter. Why do you ask?
Because I try to ask all my guests if they like peanut butter, because I love peanut butter, and I just want to see what we have in common.
Oh, that's really funny. Yeah, I love peanut butter. You got
so excited about that, though. Now I know and the fact that you mentioned a Gonzo stunt, like I knew right. I was like, oh, we're the same generation here.
Yeah, exactly.
I knew I was talking to my people. So what's your favorite kind of peanut butter?
I think I'm unusual in that I like both chunky and smooth.
You're not unusual. You have a family.
Yeah. Did you mean like brand?
I
'Cause I
actually,
don't.
I actually did mean crunchy or smooth,
Mhm.
and so I like both as well. All right, but now you brought it up. What's your favorite brand?
Well, I mean, I haven't tried them all here in the UK. I don't know if they have it in the US too, but we have something called Whole Earth peanut butter, and that's the one I started using when I had kids because I was like, you guys have to have like the really fancy peanut butter, and then I was like, oh, this stuff is good.
Well, it sounds
So
very
that's.
healthy. Also, Whole Earth. I mean, it's a good name.
Oh, I didn't mean to like give them brand sponsorship accidentally,
Oh, it's
but
okay.
you know
They
what? I
won't.
may as
They
well.
don't know.
Yeah, exactly. Nobody will know.
Awesome.
Yeah.
Hey, Sally, this has been so much fun and so fascinating. Thank you so much for spending your time with me, and congratulations on a really awesome book.
Oh, thank you so much for having me on.
Yes, ma'am.
Thanks for listening, everyone. Now get outside and play.